So hello everyone, welcome to Concepts in Chemistry YouTube channel. So हम लोगों ने ऑलरेडी बार्क 2022 फर्स्ट फेज एग्जाम का मेमोरी बेस्ड क्वेश्चन आंसर डिस्कशन ऑलरेडी फर्स्ट पार्ट में ऑलरेडी 14 क्वेश्चंस हम लोगों ने डिस्कस कर लिया. सो दिस इज द पार्ट 2 ऑफ मेमोरी बेस्ड क्वेश्चन and maximum possible answer discussion. So let's start. So this is question number 15. We already discussed 14 questions in part 1. Now this is part 2, question number 15. So in the questions, this this molecule was given, and NaCl pyridine in presence of light. This is the reagents. So we already know the Barton nitrite ester reactions. So we know that the gamma, normally the delta hydrogen. So delta means this is alpha, beta, gamma, delta. Delta hydrogen, in that delta hydrogen, normally in delta hydrogen that uh, the NO group attached at delta hydrogen in Barton nitride ester reactions. But in this case, alpha, beta, gamma, delta hydrogen is far from this OH group, but in this structure there is no delta hydrogen in these positions. So these are methyl group, one closer to OH, one far from OH group. So in the given option also there was no NO group attached with these positions. So options, 4 options is like, one option is this NO is this positions, NO is this positions, another options NO is in that position, this is gamma position, alpha, beta, gamma. So actually I don't know, but normally in Barton nitrile ester reactions, the NO that nitrosyl group will attach delta position with respect to the OH group. So this is alpha, gamma, this is alpha, beta, gamma, delta. This is omega positions, but according to the options, there are 4 options. 2 options is, one NO is this here, not in this way. So there should be on, bond like this. So another option is like this in this positions, but since this methyl group is closer to OH group, that's why the correct options might be this. But among the 4 options, only one delta position is there, that is alpha, beta, gamma, delta, alpha, beta, gamma, delta. This is the delta position with respect to OH, but it's far from OI. So the 6-member transition state, so the formation of 6-member transition state is impossible for this case, these positions. That's why the NO group cannot be attached here. So this is the omega positions. So according to my opinion, the correct, most possible correct answer is this. Still the NO group attached in a omega position, but normally in Barton nitride ester reactions, the NO group normally attached with delta position. So this is the mechanism. First pyridine abstract this H atom O, this O minus react with this NaCl to form ONO. So now in presence of light, this bond will break as homolytic cleavage will occur in this bond. So O radical O dot and NO dot release. So this radical abstract on hydrogen from these positions to release a alkyl radical. This alkyl radical now attached with this NO dot released in this step. This NO dot, there should be on dot. So now this uh, alkyl radical attached with this NO dot to form a this kind of molecule, alpha, beta, gamma, delta. So फोर ऑप्शन में वन ऑप्शन एनो इस कार्बन में अटैच था, सेकेंड ऑप्शन में इस कार्बन में, ये कार्बन में पॉसिबल नहीं है बिकॉज दिस कार्बन इज क्लोजर टू ओएच. So the transition, cyclic transition state, the most appropriate cyclic transition state will be occur in this case. So normally 6-member transition will occur, but in this case 7-member transition will occur. So among the four options to find the most appropriate, I think that this was the most appropriate options. So this is from Barton nitride ester reactions. We all know the mechanism. Uh, so from radical chemistry, there are so many name reactions, Hoffman, Loeffler, fatigue reactions. So since this time they uh, asked on questions from Barton nitride, maybe in the second exam, means BARC second phase, 6 April, they may be asked from the radical reactions with from another name reaction like Hoffman, fatigue, Loeffler. So many name reaction is there, include in the radical reactions. So you will check some radical reactions. I think that will help you a lot for the upcoming reaction, upcoming exam. So let's move to the next questions. So this question is so hydrochloric chlorate acid, so HClO4. So this is a pinacolone rearrangement. So in this case, see, there is uh, two way. In this case, there is two possibility to form the carbocation. If this OA is protonate, then after leaving this OH2, here one carbocation is formed. If this OH is protonate, then after leaving this OH2 group as a water, carbocation is in this position, carbocation is formed. So we all know that carbocation means carbocation in a cyclic structure is unstable. So this is normal carbocation, 3D carbocation. This is also a 3D carbocation. After leaving this OH2 group, this carbocation is formed. This is 3D carbocation. If this OH group leaving as a OH2, then also there the carbocation formed in this case will also be a 3D carbocation. But among these two 3D carbocation, this is a cyclic and this is a open carbocation. So positive charge in a cyclic structure is unstable. Still both are 3 degree, but this is somewhat unstable than this open 3 degree carbocation. So that's why this OH2 first protonate and release on water group to form a 3D carbocation. Then this lone pair push and this bond break to form a 7-member ring. So this is the correct answer. So this is also a simple questions from organic chemistry. A simple concept is there. Carbocations, if this O is protonate, then there also be a chance to form 3D carbocation. If this O is formed protonate, then chance is 3D carbocation formation. But if this carbocation form, this is a cyclic structure. So positive charge in a cyclic structure is unstable than normal 3 degree carbocation. So that's why this OH2 OH group protonate to form this carbocation. Then this OH leave and this bond break to form 7-member ketone. So this is the structure. This is somewhat conceptual questions, but uh, so I put on questions, extra questions regarding related these reactions. So since मुझे लगा ये वाला क्वेश्चंस ये लोग पूछ लिए, सो नेक्स्ट जो एग्जाम होने वाला है 6 अप्रैल को, उसमें इस टाइप का एक क्वेश्चन पूछ सकते हैं. सेम क्वेश्चंस अगर ये AClO4, ये लोग अगर इंस्टेड ऑफ यूजिंग AClO4 if they used BF3OT means Lewis acids, then what will be the product. मे भी ये लोग क्वेश्चन कर सकते हैं, इसलिए मैंने ये वाला क्वेश्चन यहाँ जोड़ दिया. So same questions if BF3 we use as a Lewis acids. So now opposite result you will observe. Why? The reason is, so BF3 is a Lewis acids, so you have to consider the lone pair of OH group. If BF3 is a Lewis acid, we are using BF3 as a Lewis acid, then this lone pair has to attack the BF3 to form the Lewis acid adduct. Now see, this OH lone pair is somewhat shielded by this methyl hydrogen. There is methyl group on a methyl group, so there is 2 methyl group, and this methyl 3 hydrogen atom is there. So this OH lone pair, this lone pair of this oxygen somewhat shielded by this methyl hydrogens. But in this case, lone pair of this OH, lone pair of this oxygen atom is not shielded as much as this OH group, because see, this there is 2 hydrogen, 4 hydrogen, but these are in a ring. So these hydrogen are in a ring, and that ring is rigid ring. So these two hydrogen are in the ring. But see, in this OH there is 2 methyl group, means 6 hydrogen, and this 6 hydrogen somewhat make a shield or make a screen with respect to this lone pair of electron of this oxygen atom. So in this case, the lone pair of the oxygen atom somewhat shielded by these methyl groups, these 2 methyl groups. That's why this lone pair is somewhat less available than this lone pair. This lone pair, the adjacent hydrogens are in a ring conformation, so lone pair of this OH is somewhat more available than this lone pair of oxygen. So lone pair of oxygen in this OH is somewhat more available than lone pair of oxygen is on this oxygen atom. So that's why this lone pair of oxygen attacks BF3 to form the Lewis adduct. Now this bond break and to form a carbocation, and this OH push and this methyl group migrate. So in the former case this bond migrates, in that case this methyl group migrates. So you can show both way in a concerted or a discrete mechanism. First carbocation form, then bond break, but in this case I showed that concerted mechanism. Bond breaking means leaving group leaves, migration same step, and lone pair electron pushed by oxygen. So in this case this product will form. I hope you can you will understood that what I am trying to say. Same questions if we change the acid source, in this case perchlorate HClO4, and in this case BF3 is a Lewis acid. So exact opposite result we will observe. So ये क्वेश्चन किसी भी एग्जाम में पूछ सकते हैं, so that's why I put this example. So let's move to the next questions. So 4 solutions are given, and among the 4 solutions, which solution have lowest ionic strength? So 0.2 molar NaCl, 0.1 molar NaCl plus 0.2 molar KCl solution, 0.2 molar FeSO4 solution, 0.2 molar FeSO4 plus 0.2 molar FeCl2 solution. ऐसा कुछ solution ये एग्जैक्ट वैल्यू एग्जैक्ट मैच नहीं होगा, शायद ये इलेक्ट्रोलाइट मैच हो सकता है 90% चांस है, बट 90% 95% चांस है जो वैल्यू मैच हो जाएगा, बट कुछ जो वैल्यू इसमें दिया हुआ है मतलब मोलारिटी शायद कुछ पॉइंट का कुछ डेसिमल प्लेस चेंज हो सकता है, सो वो याद रखना बहुत मुश्किल होता है, बट स्टिल so 4 solutions. Now we have to focus on the exact theory and some concept. So we all know the ionic strength I equal to half summation of Ci Zi square. Ci means concentration of the species, Zi charge of the species, Zi square. So for first case there is sodium chloride. First case sodium chloride 2 molar solution. So sodium chloride Na plus, so in concentration of Na plus is equal to 0.2 molar, concentration of Cl minus equal to also 0.2 molar. So half into concentration of Na plus 0.2, charge of Z whole square, charge of Na plus plus 1 whole square, concentration of Cl minus 0.2 molar, concentration of charge of Cl minus minus 1 whole square. So 0.2 plus 0.2 by 2, 0.2. First case I. Second case there are two mixture of electrolyte, 0.1 molar NaCl, 0.2 molar KCl. So 0.1 concentration Na plus plus 1 whole square, this is Na plus, 0.1 minus 1 whole square, this is for Cl minus, this is for K plus, 0.2 plus 1 K plus charge, 0.2 Cl minus charge square. So in this way we can each case calculate the I term. So in second case 0.2 molar FeSO4, so FeSO4 means Fe2 plus SO4 2 minus, so Fe2 plus concentration, charge of Fe2 plus, concentration of SO4 2 minus, charge of SO4 2 minus. So 0.2 molar is concentration is cation and anion concentration should be 0.2 plus 2 charge whole square, 0.2 molar concentration minus 2 charge SO4 2 minus, so total 0.8 plus 0.8 by 2, 0.8. In case 4 there are 0.2 molar FeSO4, 0.2 molar FeCl2. So for Fe2 plus concentration charge, SO4 2 minus concentration charge, for Fe2 plus second case FeCl2 concentration charge, since there is 2 Cl, that's why we multiply 2 into concentration of Cl minus charge of Cl minus. If we calculate we will get 1.4. So among these 4, first case that is 0.2 molar NaCl, the ionic strength is 0.2. So for 0.2 molar NaCl, the ionic strength is lowest. So let's move to the next question. So plot of LNR versus time gives a straight line with negative slope. Order of the reaction. ऐसा ही एक्सपेरिमेंट था. So yeah, ऐसा अगर किसी क्वेश्चन में ऐसा कोई क्वेश्चन पूछ लेते हैं, कोई भी एक रिएक्टेंट का कोई भी एक टर्म, रिएक्टेंट LNR R on by R versus time and with the negative slope or positive slope, you can easily within 30 or 20 seconds you can easily solve the questions without without deriving any equations of reactions first order, second order, without thinking anything. Just you have to do some calculation within 30 seconds. I think you can do the answer. So this related on video I already uploaded in my previous video. So in that video we already discussed that this and this uh, graph. So in the questions they give ln r versus time. So if the questions give it, so ln r versus time, क्वेश्चन में ऐसा दिया हुआ है ln r versus time, negative slope, straight line. Now we have to plot a normal straight line equations. We have to write y is equal to mx plus c. It is the general equation of straight line. Now put the ln r term in place of y, because this is y axis, and put t term time in place of x. So ln r minus mt plus c. I put minus because they said with negative slope. So now differentiate these equations with t. So d dt ln r equal to d dt. Now we differentiate 1 by r dr dt minus m, because t differentiate become 1, c 0. So dr dt minus mr. So this equation is similar like a rate equations, dr dt minus k into r. So since rate is proportional to the concentration of r, so this is the reaction of a first order reaction. This is the rate equation of a first order. Since dr dt proportional to r to the power 1, means rate is proportional to concentration term, only concentration term. So that's why this is a first order reaction equation. So from this you can easily calculate within 30 or 20 seconds the order of the reaction. We already discussed in our previous video these two questions. So if we put 1 by r in that case and versus t, the line is slope is positive or stable line, then we will get dr dt as a minus mr square. So this, since dr dt rate is proportional to r square term, that's why it's a second order reactions. If 1 by r versus t, we get a straight line with positive slope. Same case, if we change the y-axis term as r, only concentration, versus t, then we will get dr dt as minus m, only minus m we will get. Minus m we can write here r to the power 0. R to the power 0 means 1. R to the power 0 means 1. So initially we will get dr dt equal to minus m, but we can write r to the power 0. We all know that r to the power 0 equal to 1. So dr dt equal to minus m r to the power 0. Since this rate is proportional to uh, r to the power 0, or you can say this is independent of reaction concentration term. In the rate there is no concentration term, only minus m is there, but I wrote r to the power 0 means 1 is there. This term means 1. Since this dr dt is independent of reactant concentration, that's why it is a zero order reactions. So in this way we can solve this type of problem with a simple manner, in a बहुत कम टाइम में ये हम लोग सॉल्व कर सकते हैं. सो ये वाला क्वेश्चन, ये दोनों क्वेश्चन नेट और गेट में पहले शायद पूछा गया था, बट ये वाला क्वेश्चन आज एग्जाम में पूछा गया, एलियन आर वर्सेस टाइम. मैंने वो वाला वीडियो में बोला था ये वाला टर्म वो लोग चेंज कर सकते हैं किसी भी, 1 by r, r2, r square, r, just we have to put the value in that y axis term in place of y, x axis term in x, and thus differentiate, and at last we will have to write these equations by rearranging. Then we have to see dr dt equal to minus m should be there. M is a constant like k, rate constant. If in this case r is there, that's mean first order reactions. If r square is there, that's mean second order reactions. If nothing is there, means r to the power 0 is there, that's why it is a zero order reaction. So luckily पहले हम लोग ये दोनों डिस्कस कर लिए थे. luckily in this case alien are there, so थ्री टाइप्स पॉसिबल, थ्री टाइप्स ऑफ रिएक्शंस हम लोगों ने डिस्कस कर लिया। पहले ये दो डिस्कस कर लिया था एक वीडियो में, आज ये हो गया, ये क्वेश्चन पूछ लिया। सो जीरो ऑर्डर, फर्स्ट ऑर्डर, सेकंड ऑर्डर डिस्कस हो गया। सो लेट्स मूव टू द नेक्स्ट क्वेश्चन। So ionic lattice usually exhibits, there was four options, Schottky defect, Frenkel defect, और दो ऑप्शन था. So normally we know that ionic lattice usually exhibits Schottky defects and covalent lattice usually exhibits Frenkel defects. So there is some explanation. So why ionic lattice usually exhibits Schottky defects and why covalent lattice usually exhibits Frenkel defect. So we will discuss in a different video that this related the defect related topics. So we will discuss in our next video. Next means upcoming video on defects in lattice. So there we will discuss detail how why ionic lattice exhibits Schottky defect and why covalent lattice exhibits Frenkel defects. So question 20, there is a cluster, boron cluster. So we have to find the name. So B5H8 minus. So if we replace, means if we remove 3 hydrogen from here, then it's become B5A5, B5H5. Since we remove 3 hydrogen, we have to add 3 negative charge here. So B5H5 4 minus means BNHN 4 minus. This is nido cluster. We all know BNHN 2 minus clozo, BNHN 4 minus nido, BNHN 6 minus arachno, BNHN 8 minus clozo, nido, arachno, hypo. In this way. So the nido is the correct answer. So entropy S can be written as, so this is not the option. The option was, so one option is like that, S minus del G del TP, B S equal to minus del A del TP. So there was two options, C and D. So I forgot the options, but there was four options, A, B, C, D, four equations like that, S equal to, but the option is like that, A options only A only, in B options A and B only, in option C that D, small d, and C and D, like in this way. जो ऑप्शन था उसमें ऐसे कुछ था, बट ऐसे ए बी स्मॉल सी डी में 4 एस का वैल्यू दिया था, बट हम लोगों को ए कैपिटल ए बी सी में चूज करना था. सो हम लोग एंट्रोपी को कौन सा वे पे लिख सकते हैं, ओनली ए एंड बी बोथ वे में लिख सकते हैं, और कुछ ऑप्शन था. सो क्वेश्चन ये था. So answer is this. So you all know from this rectangular box we can derive easily this thermodynamic equation, du TdS minus PdV, dH TdS plus PdV, dG VdV minus SdT, dA minus SdT minus PdV. So this, from this rectangular box we can derive all the formulas, all the equations in thermodynamics. Yeah, we will discuss in a separate video how we can draw from this only on rectangular box all the equation of state of thermodynamics, all the Maxwell relations, all the thermodynamic equations we can draw from this rectangular box only. So now from 3 and 4, if we divide del t, not differentiate, again I am telling you that we are dividing, not differentiating. We are dividing this equation del T at constant pressure. So del G, del T become this side, del G, del T at constant P. Constant P, if we dividing at constant P, means this dP becomes 0, means this part becomes 0. From 3, if we divide del T, these equations at constant pressure, we will get del G, del T P equal to minus S. Del G by del T at constant pressure equal to minus S. This part becomes 0, we will get only minus S. From 4, del A, del T If we divide again del t at constant v, then del a del t at constant v means this dv becomes 0, this whole part becomes 0. So del a del t at constant v become minus s. So s equal to minus del a del t v. सो चार ऑप्शन में स्मॉल ए बी सी डी में चार कुछ लिखा था इसका वैल्यू एमंग चार एमंग दिस फोर ऑप्शंस. सो बी और कैपिटल डी में कुछ ऑप्शन था जो जिसमें दोनों ही था ए एंड बी. सो हम लोग एंट्रोपी को आइदर दिस वे डेल जी डेल टी पी माइनस और माइनस डेल ए डेल टी पी में इस फॉर्म में लिख सकते हैं हम लोग. सो एंट्रोपी को हम लोग आइदर इस फॉर्म में और इस फॉर्म में भी लिख सकते हैं. सो फ्रॉम these two equations we can derive the another form of entropy. So from this formula we can write another form of pressure, volume, temperature. We can write in this differential form. We can write the we can write many form of pressure, volume, temperature, so etc. So for entropy we can write two to this type kind of form del g del tp minus del a del tp is equal to minus del g del tp is equal to minus del a del tp. So yeah guys, I forgot to mention that I think 5 to 6 questions from mathematics. So this time 5 या 6 questions था normal differential calculus differential equation. So I think 5 या 6 क्वेश्चन था, उसमें से अभी एक क्वेश्चन मुझे याद आया. So this questions is like normal. So this is a simple questions. So x square minus 4, x square minus 2 square. If we take common 2, x minus 2, now x minus 2 cancel. So x plus 2 by 2. Now if we put the value of x, then it's become root 2. So ऐसा कुछ एक क्वेश्चन था इजी. बाकी 4-5 क्वेश्चंस मैथमेटिक्स का था. सो डिफरेंशियल नॉर्मल सेकेंड ऑर्डर एंड फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन से कुछ क्वेश्चन था, अभी याद नहीं आ रहा है. सो या सो अपकमिंग वीडियो में we will try to put those mathematical questions. So differential equation में 2-3 क्वेश्चन था, बाकी अभी बहुत सारा क्वेश्चंस है केमिस्ट्री में जो टाइम लगेगा सो याद करने से. तो सो दिस इज द one of the questions from mathematics out of 5 or 6 questions. So second questions बहुत इजी क्वेश्चन था. माइक्रोवेव स्पेक्ट्रोस्कोपी मीन्स रोटेशनल स्पेक्ट्रोस्कोपी रिलेटेड. सो ऐसे ही एक सिंपल स्टेटमेंट था, एक रोटेशनल स्पेक्ट्रम लाइन्स आर ऑब्जर्व्ड. So in a rotational spectrum, these lines are observed at 120, 138, 156, 174. The value of rotational constant. So see the value is 120, 138 means 18 difference. 38, 56, 18 centimeter inverse difference. 174. So these difference are 18 centimeter inverse. So we all know the rotational spectral line we observed at 2b centimeter inverse. So for rotational spectrum, we observed lines equally spaced line, and each line is at 2b centimeter inverse. So so each line corresponds to b. So and thus each line in a rotational spectrum we observed lines. So we observed this kind of line, equally spaced lines. So the space between the line is 2b centimeter inverse. Sorry, we observed lines at 2b, at 4b, at 6b. In this way we observed we observed lines in a spectrum. First line is at 2b, second line is at 4b, third line is at 6b, I think in this way. But and the space between each line. So the space between each line is 2b. So we observe normally equally spaced line in a rotational spectra, and the space of the line is 2b centimeter inverse. So in this case, 2b equal to 18 centimeter inverse. So b rotational constant equal to 9 centimeter inverse. So ऑप्शन में 9 था, 18 भी था. So rotational constant, उन लोगों ने पूछा वैल्यू ऑफ रोटेशनल कांस्टेंट, दैट्स व्हाई वी हैव टू find the b. B is equal to 9 centimeter inverse. So 2b is the space between two lines, that is 18 centimeter inverse. So you can see they give normally four lines. So four lines are equally spaced, mean the difference between the two lines is 18 centimeter inverse. These two lines 18 centimeter inverse, these two lines 18 centimeter inverse. So 2b equal to 18 centimeter inverse, b equal to 9 centimeter inverse. We know the in rotational spectrum the lines are equally spaced and the space between each line is 2b centimeter inverse. B is rotational constant. Again, next question ये था, ट्रांस ऑन टू डाइक्लोरोइथिलीन का कौन सा which stretching is I think yeah, IR inactive. Which stretching is IR inactive? Asymmetric CAs, asymmetric CCl, out of plane कुछ एक था. So I forgot that out of plane CCl कुछ एक था, and CCl symmetric. So we all know that asymmetric bending or stretching all are IR active होता है. So in that case dipole moment change होता है. So asymmetric CA is EV also IR active, asymmetric CCl IR active. Out of plane में जो होता है वाइब्रेशन, वो भी आउट ऑफ प्लेन में जो वाइब्रेशन होता है उसमें डाइपोल मोमेंट चेंज होता है. दैट्स व्हाई आउट ऑफ प्लेन CCl और CA कुछ था, मैंने वो भूल गया, बट वो भी IR एक्टिव ही होगा. Only the CCl symmetric. So this CCl symmetric will be the IR inactive one. So CCl symmetric और CA symmetric जो होता है stretching, that are the IR inactive one. So ये क्वेश्चन था. So next क्वेश्चन था एक 13p NMR of H3PO4. So in H3PO4 13p NMR, how many lines will be observed? So in 13p NMR of H3PO4 only one line will be observed because there is only one phosphorus atom. So one peak, I think in question how many lines will be observed, because there is only one phosphorus atom. So the we should obtain only one peak because there is only one phosphorus atom. But if we want to know the splitting pattern, because I value of 13p is half, so 2ni plus 1 means 2. So in the questions how many lines or peak I forgot, but yeah, only one peak we will observe because there is only one phosphorus atom. But if they ask about splitting of that peak, then is it really split in a doublet? Because 2ni plus 1, only one peak is observed. It is I am sure that only one phosphorus atom is, but by splitting of the peak, how many lines will be observed? So lines, that is a doublet because 2ni plus 1. No, if there is another phosphorus, then the splitting phenomena will occur. So in this case only one peak, only one line also we have observed because there is only one phosphorus atom. If there is another phosphorus atom connected with this phosphorus, then we will consider the splitting because this phosphorus is splitted by this phosphorus atom and that phosphorus will be splitted by that phosphorus atom. So splitting we will not consider splitting here. Only one line we will observe in 13p NMR of H3PO4. So next question in a next, and this is the last question of part 2. We will try to upload more videos as soon as possible. So yeah, 3 mole of 3.9 to, yeah, I exactly remember the value 3.9 to 3.4 it changed, but 3 mole of HCl, 3 mole of HCl or कोई भी एक acids, if we added 1 liter solution of buffer, then the change pH from 3.9 to 3.4. 3 mole is there. I forgot the acids because pH decreasing means we are adding acids. So 1 liter of solution of buffer, pH change 3.9 to 3.4. What is the buffer capacity of solutions? So we know that the buffer capacity, we can define the buffer capacity in this way: number of moles of acids or base per liter of buffer. So number of moles of acid or base we add per liter of buffer uh, divided by change in pH. So the definition of buffer capacity is number of moles of acid or base we add per liter of buffer divided by change in pH, that is x by dpH beta. Beta is equal to buffer capacity x number of uh, moles of acid or base we add per liter of buffer upon change in pH. So here change in pH is 3.9 to 3.4 means 0.5, and we add 3 mole of acid in 1 liter solution. Here see here per liter of solutions, so 3 mole of acids added 1 liter solutions mean 3 moles of acid added per liter of solutions, so 3 by change in pH 0.5, so equal to 6. So the buffer capacity of this solution is 6. So thank you guys, thank you for watching. So we already discussed 26 questions. Among 26 questions, I think we have still doubt to you still more than 80% doubt to 3 questions, but otherwise I believe that 24 to 23 क्वेश्चंस हम लोगों ने सही आंसर डिस्कस किया, जो किया आंसर सही होना चाहिए, और बाकी एक दो क्वेश्चन में सम चेंज भी हो सकता है आंसर का. सो लेट्स सी. Yeah, we will upload more videos as soon as possible, so stay tuned. Thank you for watching. Stay safe, stay healthy.